All right, we're going to prove some facts about isomorphism. The exercise I'm going to look at is 1128b, which is similar to 1128a. Right? But what this says is given a function phi from g to h and psi from h to k, psi or psi, and these are both isomorphisms, I should say are isomorphisms. Show that psi composed phi, which goes from g to k, is also an isomorphism. Right. So see how this works. Phi takes g to h, and psi takes h to k. So if I take psi composed phi, remember you do phi first. So it's going to take g to h, and then the psi will carry it over to k. So this is a correct composition. And we need to show that this is an isomorphism. Now, what's an isomorphism? That's from this definition right up here. Two groups, G and H, are isomorphic if there exists a bijection, G to H, such that the group operation is preserved. Okay, so we have this equation. We have two facts here in this definition. First fact is bijection. Second fact is this equation must hold. All right. So in this problem, we know that phi and psi are isomorphism. So they're both bijections, and this equation holds for both of them. It holds for phi, it also holds for psi. Now we want to show that psi composed phi is also an isomorphism. So we need to show two things. The two things we need to show are that, let's open this again. We need to show, first of all, that psi composed phi is a bijection. That's the first thing we'll need to show. And then the second thing you'll need to show is that this equation holds, the isomorphism equation holds, or I should say it this way. Let me just say that psi composed phi preserves group operation. Now what does that mean? That means that I replace phi here with psi composed phi. I just make that straight replacement. Phi changes to psi composed phi. So psi composed phi of A dot B is equal to psi composed phi of A. Now here there's a circle here. This is the operation in the group H. Now there's a little bit of a problem here. This is the operation in the group H. This here is composition. So I'll indicate this when I finish writing. All right. So this is going to be psi composed phi of H, and then here I'll just write it. Maybe I'll use a star here or something to indicate the different operation. And this is psi composed phi of B. All right. So let me explain all the symbols here. This here is the group operation. It's the group operation in G. Okay. This here is function composition. And that's the same here. This is also function composition. This here is the group operation. It's the group operation in the range of psi composed phi. Now, where's the range of psi composed phi? Well, remember, phi takes g to h, psi takes h to k. So this is the group operation in k. All right? So what you're doing is you're taking A dot B, where A and B are both elements of G, and by means of psi composed phi, you're carrying that element over into k. And then you're saying that, okay, if I carry A over into k, and B over into k, and then operate using the group operation in K, I'll get the same result as if I take A, operate with B in G, and carry that result over. So I can do this diagram again like we've seen before. Here we have A dot B. I'm sorry. Here we have A and B, and these are in G. And then this goes down, and this goes to A dot B, and this is in G. And then over here, we take A and B by means of C composed phi. This is going to take me to C composed phi of A and C composed phi, that's a bad phi, of B. And this is in K, right, because this takes G to K. On the other hand, I can take C composed phi. Here again, it goes from G goes to K. Here, let me make these two dots a little bit clearer. Two dots here. And this is going to give me phi, C composed phi of A dot B. Now, if I do the multiply, this is multiply, and in G. And here we have multiply in K. And the question is, if I carry A dot B over using C composed phi, is that the same result as if I take this result, C composed phi of A, I'm going to run out of room here. Let me see if I can move it over a little bit. Is that equal to C composed phi of A, then operating in K times C composed phi of B? Right? So that's the question. Can I operate in G and then carry it over using C composed phi and get the same result if I carry over A and carry over B and operate afterwards? So that's what we're trying to show. Right? So we're going to have to do a couple of computations here. Let's start with the more complicated expression. It's not letting me go down. Okay, so let me start with C composed phi of A dot B. All right, now, what do we know about this? Is equal to psi of phi of A dot B. Now, what do we know about phi of A dot B? Phi is an isomorphism. Okay? Since phi is an isomorphism, I can write this as psi of phi of A, and then here I'll just use the dot again, phi of B, where now this is the group operation in H. Why is it in H? Because phi takes G to H. Remember up here, phi takes G to H. All right. So what I've done is I've taken one step. I'm doing this in two steps. Phi takes G to H, and so the phi of this product gives me the product of the phis. Now here, these two are living in H. Okay. Now, if I take psi of that, I know that psi is also an isomorphism. Now here I have psi of a product. Now I can use the isomorphism rule on psi to give me psi of phi of A, right? And then operated with psi of phi of B. Now what's this group operation here? This is the group operation in the range of psi, which is in K. So I can write this, as I was writing it before, I can write this as star. All right, now here I have the composition. Psi of phi of A is the same thing as C composed phi star with C composed phi of B. Okay, so actually I've completed my proof I've shown that C composed phi does preserve the operation. Okay, so that gives me part 2 of these two things that I have to show. Okay, so here, let me just go back and fix this up. Here I have the statement, and here was just clarification. Okay, and then here's the actual proof down here. Here's the actual proof of what you need. Okay. All right, so I finished part 2. Part 2 is okay. Now I didn't do part 1. For part 1, you should find the appropriate proposition in the functions chapter. All right, there's a proposition that addresses this, that if you got two bijections, what that tells you about the composition of two bijections. All right, so that's it.